Hello everyone, this is Mr. Meter and we are here with another video on a brief explanation of initiating a connection in HDLC communication, the SNRM section. Imagine a computer or metering network in which one of the nodes wants to connect to the other node and transfer data based on HDLC protocol. When device A wants to connect and transfer data to device B, they first need to initiate and establish a communication or a virtual circuit and then transfer data. Starting a connection in HDLC protocol first happens by creating the first initiation packet called the SNRM packet. This is a typical connection initiation form in metering networks. The target device will answer with a UA frame indicating the TX and RX maximum value values that the device A may use to communicate and transfer data, and also the acceptable window size for data transfer. After this, device A, based on the latter requests or data that is meant to be transferred, will request association based on the intended authentication mechanism preference, and also certain conformances which may vary depending on the data or command that is intended to be sent to device B, which is called ARQ frame. After receiving ARQ request from device A, device B will answer with an ARE frame that contains authentication and association results and the negotiated and accepted conformances alongside the maximum PDU size. Next, we will discuss the SNRM and UA frames and their structures through a sample communication packet. SNRM stands for Set Normal Response Mode and is used to place the addressed secondary station in the Normal Response Mode or NRM, where all control fields shall be 1 octet in length. The secondary station shall confirm the acceptance of the SNRM command by transmission of a UA response at the first respond opportunity, which stands for numbered acknowledge. This is a sample packet in which the client is connecting to an electricity meter over TCP connection to a gateway which is transmitting data transparently to a meter from the client. This is an example of a connection-oriented communication over a connectionless communication in which a virtual circuit is formed before transmitting data. A0 is Packet Status Indicator. A0 indicates that the SNRM is transmitted in one packet based on the window size. If it is A8, then it indicates that the SNRM is transmitted in multiple packets. 0A indicates the frame length, which becomes C in the translation process. And then 0002, 76, 71, 03, which are the logical, target, and source addresses respectively. 02 is the logical address, which must be divided by 2 and results in 1. 7671 is the target address, which translates to 7608 by dividing 76 by 2 and then subtracting 1 from the result, concatenated with 71 and finally dividing by 2. This, in this case, is the target meter physical address for the RS485 electrical port. 03 is the source address, which should be subtracted by 1 and then divided by 2, resulting in 1. 93 is the frame type indicator, which is SNRM frame based on DLMS Greenbook. And at last, 1F46 is the FCS checksum indicator. After device B receives the SNRM packet, if the packet is valid, it replies with an unnumbered acknowledgement or UA frame. The packet is longer than the SNRM because it contains the communication characteristics and the receiver capabilities. This packet is the reply from the electricity meter, which SNRM frame was sent to, and here we go deep into the packet details. There are three main parts to this UA packet. The first part, which contains the frame type, source, destination addresses, logical address, and the packet length. The second part, which contains the packet data, that is in this case the UA data, and the last part, which is the FCS data. Let's delve into the details of a UA packet. After 7E as the starting indicator of the packet, A0 is packet status indicator. A0 indicates that the SNRM is transmitted in one packet based on the window size. If it is A8, then it indicates that the SNRM is transmitted in multiple packets. 21 means the frame length, which becomes 20 into translation. And the next is 03, 00, 02, 76, 71, which are source, logical, and target addresses respectively. 03 is the target address, which should be subtracted by 1 and then divided by 2, resulting in 1. 02 is the logical address, which must be divided by 2 and results in 1. 7671 is the source address, which translates to 7608 by dividing 76 by 2 and then concatenated with 71 and then subtracting 1 from the result and finally dividing by 2. This will result in 1dB8, which in decimal is 7608. This is, in this case, the meter physical address for the RS485 electrical port. 73 is the frame type indicator, which based on DLMS Greenbook, it is a UA frame. 3DC9 is the HDLC HCS frame indicator. After that, we have 8180, which 81 is the format identifier and 80 is the group identifier. The next part of the packet contains 12 as group length, which translates to 18 octets, and 05 as the maximum information field length for transmit, and finally the parameters length, which is 01, which translates to 1 octet. This means that the maximum TX information field length is 128. The next 80 is the parameter value, which is followed by 06 and 01, which are maximum information field lengths for receive, and the parameter length, which is 01, that translates to 1 octets. This means that the maximum RX information field is also 128. The next 80 is the parameter value, which is followed by 07 and 04, which are transmit window size translating to 1, and the parameter length, which is 04, that translates to 4 octets. The next part are the default parameter values. The next 08 is the parameter value, which is followed by 04, which is receive window size translating to 1. And also the next part are also the default parameter values. And the last is 533B, that is FCS checksum indicator, which is followed by 7E as the packet ending indicator. This was a brief explanation of initiating a connection in HDLC communication, the SNRM section. On our next video, we will cover the ARQ and ARE sections of the connection initiation phase. Please hit the subscribe button, and we will be talking much more on network protocols, transmitting data modes, and all about applications of data measurement and transmission in electricity grids and metering industry. Also, please feel free to send all your questions, and I will be making a video answering all your questions. Thank you.